Okay, welcome. This is the week 4 webinar for the online statistics class. And the plan today, it might even be a little bit shorter than usual because there's not that much to talk about. So that's the good news. And one of the reasons is that this is a good time for you to really push the project. Project is due on February 9th, I believe. So, a little less than 2 weeks. So you really got to get moving on that. And by now, I was hoping I'd see a bunch of people who had posted on the Project One discussion board their idea for the project so I can give you advice and feedback and all that. And I check the board, multiple times a day. So make sure that you do that so that I can help you out because I want to help you out. So the plan today, as always, I'll answer any questions if you have any questions. And then we'll talk about the standard normal distribution. It turns out the normal distribution, I would say on a scale of 1 to 10 in terms of distributions of importance, it's the 10. It is by far the most important distribution of all distributions. And unfortunately, you're really not going to understand why until next week when we have something called the central limit theorem. For now, you just got to trust me that it's really, really, really important. So we'll talk about the standard normal distribution and we'll calculate probabilities and percentiles if we're given a standard normal distribution. We'll see how we can kind of do that for some cases without too much difficulty. And then we'll talk about the general normal distribution. And basically that takes the standard normal distribution, but with the standard normal distribution, it turns out your mean is 0, your standard deviation is 1. And with the general normal distribution, mean could be anything in the standard deviation, can be any positive number. And that way you can have that. The general normal distribution is that one that comes up a lot. You can transform it into the standard, but nowadays with technology, you could just use the general. So I'm going to talk about how do you compute probabilities and percentiles using the general normal distribution. And then we'll go and do a couple applications. And their idea about applications, again, next week is when we find out the reason why everything is like so many things are the normal distribution. We've talked about the normal distribution already a little bit, if you remember, in the first week of class. And that was, if you remember, it was kind of bell-shaped, but we're going to be using normal instead of bell-shaped because that's a statistics word or to use for at least for our class. So we're going to be, doing a couple applications, kind of fun little problems. But then next week we'll really see how it's used. So I want to let you know, this is the week 4 webinar, and this is week 4. What's important about the number 4? Why is the number 4 important? Yeah, it's a it's an even number. Hopefully you know the number 4 is an even number, which means you have an exam this week. So you will have your week 4 exam to do. And I want to let you know the rules are the same. So you get 90 minutes to do the exam. And the way it's going to work is that about half or so of the exam, maybe a little less than half, or maybe a third of the exam or so, will be basically the same stuff you saw in the week 2 exam in terms of content. It randomizes questions that were on the assignments and gives those to you. Then there'll be another bunch of problems that come from the last couple weeks, this week and last week. And those, if you remember, that was chapters 4 and chapter 5. So we're looking at the binomial distribution. We're looking at discrete variables, expected value, standard deviation. We're looking at uniform distribution, quantitative versus qualitative, all of that stuff. And then also you're going to be doing the normal distribution. And then just like in the week 2 exam, the last few problems will be where you type out your answer. Okay, so that's really important. And again, it's very important that you pay attention to the webinars because I often will tell you these are the things that you have to put in when I ask you something. And if you don't use those words, I'm very harsh on points. So it's really important that you don't just scroll down, speed up the webinar until you find the secret word because it won't be good for you. It's important that you watch the webinars and you take lots of notes. And especially when I tell you you have to use these words, you really do. Okay. And I noticed some of you didn't on the discussion post assignment for last week, and you lost some points for that. Okay. So that's just a note. Make sure you use the words I tell you during the webinar. So that's important. So again, there's a lot of stuff. There's the exam and then the project. You should be, putting in some good time on the project. Any questions at all? I'm always happy to answer questions about anything and let you know. This webinar might be a little shorter than usual. It's just one chapter. It's a little lighter because you have an exam and you have the project coming not too long. But still, I'm here for questions. Any questions? Okay, if you don't have questions, then I'm going to remind you about something we saw a couple weeks ago, and that was the empirical rule, it was called. And let me show you the picture of it. Again, we looked at this a little while ago, and that is if you have a normal distribution. So here's a normal distribution. It's often called a bell-shaped curve or a bell curve, but we're going to use the word normal, and you need to use the word normal, by the way. And we know that the probability of being between -1 and 1, if you have a standard normal distribution, that means the mean is 0 and the standard deviation is 1. So you're within one standard deviation of the mean. That's 68%. Okay. The probability of being between within two standard deviations of the mean, that means between -2 and 2, that's 95%. And then the probability of being within 3 standard deviations of the mean, that's -3 to 3, that's 99.7%. So very small chance of being outside of 3 standard deviations. All right. I will let you know that if you remember the way we talked about finding the probability when you have a distribution like this, when you have a continuous variable, is the area. So it's the area between those numbers under the curve, kind of like that filled in place between -1 and 1. And I'll also let you know that there's no way, unless you've had a serious amount of math, there's no way you're ever going to do it by hand. Just let you know. Even our embedded tutor Hector, I don't think you maybe could do it. I'm not sure, but it's a really intense. So what we're going to use is the calculator to find these things, but it's important that you know the 68%, 95%, and 99.7%. Any guess on which of the three are most important? 68%, 95%, or 99.7 of the three? Which is used the most? What's your thought? Which of those three? Because one is actually much more important than the others. It's a good guess. It's not 68%, it's the 95%. Okay, and I don't know if you remember, but I told you a while back that we define an outlier to be farther than 2 standard deviations from the mean. So basically what we're saying is that if it's an outlier, being an outlier has a 5% chance of happening, which is a pretty small percent. Does that make sense? So that's one reason why this 95% is used, is that's kind of what we're talking about as outliers. And later in a few weeks, we'll talk about confidence intervals, and 95% is a standard confidence interval, but that's not today. Any questions on that? Okay, so let's see if we happen to have a standard normal distribution, find the probability that if you randomly pick something out of a standard normal distribution, that you're going to get between -1 and 1. Okay, and I want to show you something. The way you write the distribution, first thing we're going to use the letter Z for the standard normal distribution. And then this tilde, we did this last week. The tilde means has the distribution of. So that's this tilde symbol. And then N stands for normal. 0 means the mean is 0. So right at the center of this distribution is the number 0. And 1 means the standard deviation is 1. So that means kind of this distance. I'm not going to get into all the details because you need calculus for it. So we want to find the probability that Z is between -1 and 1. In symbols, that's P parenthesis -1 less than Z less than 1 end parenthesis. The hint is it's very easy. What is the probability that Z will be Z between -1 and 1? This is very easy. You don't need a calculator at this point. It's not 1 because if it was 1, that would mean you'd have a 100% chance of that happening. But you could be way over here. That could happen. You see there's a little part of the curve there. There's some kind of shaded region in there. So it's not 1. And it's very obvious. Give you a few seconds. Hopefully you'll see it. 1 between -1 and 1. Let's see jumping in right here. That's the 68%, or 0.68. Does that make sense? Because it says that the area under that curve between -1 and 1 is 0.68. Any questions on that idea? Because that was the easy question. Now we'll get to the harder ones. Okay, so now find the probability that Z is less than 3. So here's 3 over here. We want to find out the probability that Z is less than 3. Any ideas how we might want to do that? Okay, I guess as you may not come up with it because it involves a little bit of math, nothing too hard though. So the way you do is you say Z is less than 3 is all of this stuff to the left of 3. Well, we know in between -3 and 3, all of that stuff is 99.7%. So if we can also get how much is to the left of -3, right over here, then we can add this part to the far left to this 0.997. So I can write that is this is equal to the probability that -3 is less than Z is less than 3 plus the probability that Z is less than -3. Any questions on that so far? Okay, the probability that we're between -3 and 3, that's the 0.997. So that's 0.997. And now we want to say, what about between -3 and 3? I mean, less than -3. Well, we know the probability of being somewhere is always 100% chance of something happening, right? So what we can say is this less than -3 is the left tail. There's also the right tail, which is greater than 3. And this graph, and hopefully you can kind of see it visually, is symmetric. So those two tails are going to have the same area under them. So if we want just one of the tails, we can take the two tails and divide by 2. How do we get the area of the two tails? Well, we know the entire area is 100%. The area in between -3 and 3 is 99.7%. So if we subtract, then that'll give 1 minus 0.997. That'll give us in between -3 and 3. Outside of that, it'll give us outside of between -3 and 3, and then divide by 2. So that's going to be plus 1 minus 0.997, and then just that piece divided by 2. Any questions on that? And then you can just pop it in a calculator. I think I'll just do that. Google's good about calculators. And it gives me 0.9985. Any questions on the process of coming up with that? The little geometry. Kind of putting areas together, pulling them apart, that kind of stuff. Any questions? Okay, let's try another one. Let's find the probability that z is between -1 and 2. So that's the probability -1 less than z less than 2. Okay, so that's from this -2 over here. This -1 over here to this 2 over here. Okay. Any questions on at least what we're looking for? Okay. So we could do something similar. We can say that's going to be the probability between -1 and 1 plus the probability between 1 and 2. Any questions on that idea? Probability between -1 and 1 is 68% or 0.68. Plus, now we want to go between 1 and 2. Okay, we know that between -2 and 2, that's 95%. Between -1 and 1 is 68%. If I subtract those two, I'm going to get these two pieces between -2 and -1 and between 1 and 2. There's symmetry, so I want half of that. So I'm going to take half of that subtraction. So that's going to be plus, and I'm going to subtract 0.95 minus 0.68 and divide by 2. Any questions on that idea? And then I can easily just drop it in the calculator. And it gave me 0.815. Is that clear? Have I lost any of you? Okay, let's continue on. Find the value of z such there is a 2.5% probability of being greater than this value. Okay, so this is kind of a backwards question. Here we're given the probability and we want to find z, where the other examples we were given z and we want to find the probability. So in this case, if we want to, find z such that there's a 2.5% probability of being greater than this value, first thing, it says only a 2.5% probability of being greater than the value of z. You're going to be really high, right? You're going to be a big number. So you're going to be somewhere out here. You're not going to be on the left-hand side or right in the middle. You're going to be somewhere on the right. Because if only 2.5% of the people are taller than you, you're tall. You're a big height. Does that make sense? So it's good to see that. So first thing will be a positive number. Okay, the next thing we're going to do is something that we did before, and that is we say that kind of that right tail is 2.5% or 0.025. So I'm going to also look at the left tail on the mirror image, which will also be 2.5%. So notice that the sum of the tails is 0.025 plus 0.025, and that is equal to 0.05. Okay, so if 5% or 0.05 is the probability of being in one of the two tails, what's the probability of being in the middle, not in the tails? If you have a 5% chance of being in the tail, what's the percent chance of not being in the tail? Should be an easy question. So what's the percent chance of not being in the tail if there's a 5% chance of being in the tail? You can pop in the chat box. What is that percent chance? It's not a trick question. See y'all jumping in. It's kind of like if you're being in the tails means you lost. There's a 5% chance of losing. What's the chance of winning? I don't see jumping in. If there's a 5% chance of losing, then 100% minus 5% is 95%. So there's a 95% chance of winning. So that means that between the tails is 95% of the area. So now we just go and look here. We got this 95%. That's between -2 and 2. But we know we're on the high side, so the answer is 2. Any questions on that? Did I lose you? Any questions? Again, it's always good to ask questions if you something you don't quite get. Any questions? Not, let's move on to the next one. There's a lot of these. Okay, find the 16th percentile. This turns out to be very similar to the one we last did. Okay, but if you're in the 16th percentile, are you on the big side or the small side? So if you're in the 16th percentile, you're the high side or the low side? The big side, small side. What are you on? What side? Yeah, you're on the low side because 16th percentile, that's what it means. Only 16% are below you. Most are above you. So if you're on the low side, that means you can be a negative number. That's just a note. So let me write that down since the 16th percentile is on the low side. It'll be negative. Okay, the 16th percentile, that is how much is on the left tail. So the two tails measure or have area 0.16 plus 0.16. And by the way, 16 plus 16 is 32. So that's 0.32. So if there's a 32% chance of being between the two tails or within the two tails? What's a percent chance of being between the tails inside? If there's a 30% chance of being outside, what's the percent chance of being inside? Or you could say not being in the two tails. What's that percent chance? Let's see, all jumping in. It's the same thing we just did. It's going to be 1 minus 0.32, which is 0.68, which is very good because we have the 68%. And we already said that we're on the low side, it'll be negative. So we're over here, and that's -1. Any questions on that? Any questions? Okay, let's suppose that z is equal to 1.3. Let's find the z-score for this value. And remember, the z-score by definition was x minus mu over sigma. So that is going to be equal to x is going to be, in this case, 1.3 minus mu. Mu is a mean, which is right in the center, and that happens to be 0. It's a standard normal distribution. And the standard deviation of the standard normal distribution is 1. What is 1.3 minus 0 divided by 1? You should be able to probably do this without a calculator. It's not hard at all. What's 1.3 minus 0 all divided by 1? What do you get? Yeah, 1.3. So notice that that's what our z-score was, and that's the reason why we use this letter z for the standard normal distribution, because it is its z-score. Any questions on that? Okay, let's do another example, and this one's going to be very different. Okay, now let's suppose that x, notice we're not using z anymore, follows a normal distribution, but now the mean is 114 and the standard deviation is 23. So this is not a standard normal distribution, it's a normal distribution, just normal. And we can say x tilde n 114 comma 23. You always write the mean first, standard deviation second. So if I ask you to write down the distribution, this is what I'm asking for. I'm asking for this kind of thing, x tilde n. It's going to start there when you have a normal distribution. So don't forget that. If it happens on the exam, you need to type that in. And again, that's easy to type because the tilde is on every keyboard, basically. Okay, and all the numbers and stuff are too, obviously. Okay, we want to find the probability that x is between 100 and 120. Okay, this is going to be very different because this is not the standard normal distribution. So we're not going to use that picture. We're not going to use that 68%, 95%, 99.7%. They're not going to help us at all. Any guess on how we're going to do this one? Any guesses? I don't see you jumping in, so let me tell you. We're going to use a calculator. And what calculator number do you think we should go to? What calculator should I use? Because that is important. It's always important you're using the right calculator. Yeah, this is 8, normal probability. I tried to make it obvious. Okay. I made this calculator. I tried to make it really obvious which one to use by using words that relate to what we're doing. And we're finding a probability of a normal distribution. There's a normal probability. Okay. And it says first decide on the less than, greater than, or between. Then fill in all the values except one below and hit calculate. The last value will then be given to you. Okay. So do we want, let's take a look. We want the probability that 100 is less than X is less than 120. So do we want less than, greater than, or between? Which of the three? I don't see you jumping in. Take a guess even. You got 1 in 3 chance of guessing right, even if you have no clue. But my guess is you have a clue, so you can look again. Here's the probability. Here's our X. Do you want less than, greater than, or between? See you jumping in. Okay. Notice X needs to be less than 120, but it needs to be greater than 100. Another way of saying it is X is between 100 and 120. So we want between. And then all of a sudden the numbers pop in. We have 100 and 120. Any questions so far? Then we know the mean is 114 and the standard deviation is 23. So the mean is 114. The standard deviation was 23. I leave the probability blank because I'm supposed to leave the one value we don't know blank. And then hit calculate. And there is our probability. And the probability is 0.03315-ish. Probably don't ever need that many decimals. And there's our answer. Any questions on this using the calculator? Okay. We could do the same thing. Probability that X is greater than 200. So now we want greater than. Greater than 200. And the probability, I need to leave blank, so I'm going to erase the probability because I want the probability. Same mean and same standard deviation, and hit calculate. And there we go. Very small chance, by the way. So that's 0.00092 with a bunch more. Which makes some sense because notice to get to 200, you have to add a bunch of these 23s up from 114. So it's like way up there. And that's why it's so small. It's a lot of standard deviations above. Similarly, the probability that X is less than 90. So now we hit the less than sign. And then 90. And empty the probability. And I calculate. About 148, say 0.14836. And more that you usually don't need. Any questions on that? Okay, this next one I did, if you wanted like a given problem, you can use this formula, probability of x greater than 105, given that x is less than 125, and you turn it into a division problem and then divide. I'm going to skip that one for now. We'll do something similar later, though. Find the IQR. Do you remember what IQR means? Nothing to do with IQ, by the way. And what the IQR is? Yeah, interquartile range. And the formula for that, if you remember, was Q3 minus Q1. Any questions on that? So we want to find the interquartile range. So Q3 means they're 75% below our number, which we don't know the number. So we know the probability of being less than something will be 75% or 0.75. So if I go to the calculator, I want the probability of being less than something which we don't know, and we want it to be 0.75. Same mean and standard deviation. And I hit calculate. And I get 129.51 or so. And then minus, and that's the same idea, but Q1 means that's the probability of being less than something is 0.25, 25%. So now, instead of 75%, it's 25% or 0.25. And let's let the that blank, hit calculate, and I get 98.4867 or so. Any questions on that? Okay. And by the way, I'll let you do the subtraction. Then you just subtract the two. I'll stick it in a calculator. You get around 31-ish. Any questions? Okay. The middle 84% of the data is between what two values? Okay, the middle 84% of the data is between what two values? So the idea on this one is we're going to have to, again, think about the picture again. And if the middle part is 84%, then the outside is 1 minus 84%. Okay, or 100% minus 84%, which is 16%. Okay, and then that means the left tail will be half of that, which is 8%. So note that that means the left tail is 0.08. Okay, probability. And now we can use our calculator for that. Because 0.08 is the probability of being less than something. We don't know the something. So I erase it and hit calculate, and you get about 81.68. So one of the values is 81.68. So the lower value is 81.68. Any questions on that? Okay, the higher value can actually don't even need that heavy calculator. We can do it in a nice way. So we know there's symmetry. So the lower value is, remember the mean here was 114. So the lower value is 114 minus 81.68 from the mean. It's kind of what definition of subtraction is. It's how far away you are. So the upper value is that amount above the mean. So is 114, there's a mean, plus 114 minus 81.68 because of symmetry. And that one, I'll just pop it in. And that's 146.32. Any questions on that? Any questions? Okay, just note finding the z-score is real similar to what we did before. X minus mu over sigma. If you want to find the z-score when x is 117, you go 117 minus mu is a mean, 114, divided by sigma. Sigma was 23. And I got 0.13. Any questions at all on any of these parts? One thing I should give you a happy pointer is that this is usually one of the easier sections of the course. It's not one of the harder ones. So that's the good news. The bad news is the reason I've made this an easy week is there's a lot of other stuff going on. You got an exam and you have a project due in a couple weeks. So again, I made it so that there's not too much to do in terms of new material because you have big stuff, the project and the exam. Okay, exam is 2 weeks, but you really want to work on it this week. Any questions at all on any of these parts? All right, so now I'm going to give you an application. So here is the thing. Suppose that the time until you, or your wife if you're male, by the way, will give birth, and biologically male is what I mean, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Just a note, something might know, by saying that the mean is 140 days, what is that in like general easy talking? If you're pregnant, if someone's going to ask you a question and you're going to say 140 days, what question did they just ask you? And normal people are not going to say, what does your mean? What are they going to ask you? What sentence might they say? Just so you understand what this is all about, because it's kind of important. I don't know if either of you are going to get into the health profession, are you? I usually get students in the health profession. Any of you going to be in the health profession? Okay, so you need to know this if you're in the health profession. This is happy health, by the way, not sad health. Not like cancer. So what's the question they're going to ask? If your answer is going to be 140 days? Any thoughts? It's not a trick question. Again, pretend you're pregnant. I don't see you jumping in. Okay, maybe I'll tell you. When are you expecting? Isn't that what everyone asks a pregnant person? When are you expecting? And if you say 140 days, that's the mean. Does that make sense? Any questions on that? It's the best prediction. It turns out, and this is a health thing, the standard deviation used to be 7 days for how long for the time at which someone's going to give birth. It's not anymore, actually. It's changed, but it used to be 7 days. It's now actually less than 7 days. And the reason nowadays why it's less than 7 days is because if you're just getting too big, then you just pull the baby out. They do a C-section. So we're going to pretend that you're not going to have a C-section. And then biologically, actually, 7 days is the standard deviation of birth. Okay. So now let's write out the distribution. As I mentioned, here we have X, we have a tilde, we have an N for normal, we have 140 for mean, and we have a 7 for standard deviation. Okay, so now here is the question. It's kind of a hypothetical situation. Remember, you're pregnant, or you're going to be a dad, and that's kind of important. But your boss just scheduled you or your wife for a business trip out of the country. You or your wife leave today and will return in 135 days. Find the probability your baby will be born out of the country. Any questions on the question? Any questions on the question? Okay, if there's no questions, let's try to understand. Let's try and write, and that's very important to be able to do, write this probability in symbols. So first it's P for probability. That's supposed to be the easy part. And then what? Maybe you can put in the chat box in symbols, how do you find the probability your baby will be born out of the country in symbols, numbers, and variables, parentheses, and P. Maybe you can put that in the chat box. See if you can put in the chat box what that is going to look like as a probability. It's very important to be able to do that, or you're not going to be able to answer the question. That's usually the hardest part of this whole class, is to read this long word problem and come up with what we want. So pop in the chat box when you got it, or if you're watching this on, afterwards, and see if you can write it on paper. What's that the probability of in terms of parentheses? Hopefully you'll come up with it. You're leaving right now. I don't see you jumping in, so maybe I'll talk about it. Okay, so if the baby's born outside of the country, that means the baby is born on your return day or before. So that means that the baby is born less than 135 days from now. So that is X is less than 135. Okay, you can also say between 0 and 135, but that's a little complicated. It doesn't make any difference for this problem. But less than 135. Any questions on that? Because if you're going to be out of the country for the next 135 days, the baby's born less than 135 days from now, the baby is born out of the country. Is that clear? Okay, so now that we have that, now we can go use the calculator. So I'm going to go to the calculator. I'm going to hit refresh just to clear everything out. We want less than 135. The mean was 140 and the standard deviation was 7. And we calculate. And you get about, let's say, 23.8% chance, or 238. Any questions on that? Okay. Would you be okay with that? Would you be okay with that? Yeah, most people wouldn't. Let's suppose you want your baby to be the next, not the next president, but in another 50 years or so to be the president of the United States. The baby's born out of this country. The baby's not allowed to be president of the United States. I'm not sure if you know that, but that's part of our Constitution. So if you wanted your kid to be a president someday, then that would be terrible. Does it make sense? So because and 23.8% chance, that's a pretty high percent chance. So you probably wouldn't feel comfortable with this. So here's the deal. Okay, I'll make this a little bigger so you can read it. You decide this is too risky. You want to negotiate with your boss to ensure there's no more than a 1% chance that the baby will be born out of the country. What day should you ask to be the return date? Okay, because you don't want to lose your job, but you're okay negotiating, but you can't just say, I'm not going. But maybe you can return early enough that you're pretty confident that the baby will be born in the country. Any questions on the question? Okay, so now we know that there's a 1% chance. So I'm going to turn this into 0.01. That's 1%. And I'm going to leave the 135 blank because we want to find out when we want to be coming back home. And that means that the probability is less than that when will be 0.01. Then I calculate. And there we go. So 123.7. Okay, this is one of those you probably want to round down and not use the rules for rounding because we want it to be less than 1%. And if you rounded to 123.8, 124, then you'd be slightly greater than 1%. So I'm going to go 123 days. So you would say, ask for day 123. Any questions on this idea? Okay. That's a negotiation. All right, here's the next one. Let's suppose that it's now 138 days later and the baby has still not been born. Find the probability the baby will be born within the next 24 hours. Okay. What kind of problem is this one? Any ideas? Very important. The hint is this kind of stuff came from chapter 3. The idea does. Don't see y'all jumping in. Okay, so we know the baby hasn't been born yet, 138 days later. That's a given. Once we're given that it's been at least 138 days to get born, now we want to find the probability that they'll be born between 138 and 139. So that's the probability that 138 is less than X is less than 139, given that X is greater than 138. Any questions on reading this and turning it into a probability statement? Because again, that's usually the hardest part about probability stuff, is to understand what it's asking for. Any questions on that? Okay, then there was a formula. The probability of A given B is the probability of A and B divided by the probability of B. Okay, well, if it's between 138 and 139 and it's greater than 138, that's the same thing as just being between 138 and 139. So that's probability of being between 138 and 139 divided by the probability of being greater than 138. Any questions? Okay, so now we just compute 138 to 139. Now we're going to do it between 138 to 139. Going to erase the probability, click calculate. Oh, I forgot. I typed it wrong. 138. That's better. And you get about 0.05565. So I'm going to just copy and paste that. And then we're going to divide it by the probability of being greater than 138. So now I hit greater than 138. Drop the probability to blank, hit calculate, and that probability is 0.61245. And now what I can do is I can copy that, paste it in the calculator, and I get about 9% chance, 0.09. Any questions at all on this example? Okay, and this stuff happens a lot in all kinds of, there are so many applications. This is just one fun example of an application, but you can't even imagine how many applications there are to this. Okay. One of the things is the normal distribution. You just have to trust me that a lot of things follow the normal distribution, including including giving birth, which is interesting. Okay, here's the next one. And this will be the last one of doing, or this last, there'll be some parts. Okay, suppose that the amount of, let's suppose that you have an ice cream store. Okay, sounds good. And the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. Okay, so you could say X is normally distributed, X tilde N, comma, parenthesis 950, comma 120, and parenthesis. Find the probability that on a randomly selected day, you will sell between 900 and 1,000 ounces of ice cream. So we want the probability that 900 is less than X is less than 1,000. Any questions on this? Not too hard, but you have to be able to read the sentence and turn it into a probability statement. Okay, I'm going to go to my normal distribution again. That's the calculator for this week, by the way. I'm going to hit refresh because it's a whole new question. I want between. That was 900 and 1,000. And then we had the mean was 950. Standard deviation is 120. So 950 for the mean. Standard deviation is 120. Hit calculate. And there we go. Maybe I'll keep 2 decimals, good enough. 0.32, because as an ice cream salesperson, 2 decimals is just fine. 32% chance. 0.32. Any questions on the question? on doing this? Okay, now for part B. Okay, in the morning you took stock of your supplies. Okay, and you notice that you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Okay, what do we want? We want the probability of what? Put in the chat box. Very important that you can do these kind of things. What's the probability you're going to run out by the end of the day? What's it going to be? P parenthesis and what's the rest? Put in the chat box. Really important that you can do this. So I want to make sure you can try. Yeah, probability X is greater than 1,100. Because if you have people, the total amount of people wanting more than 1,100 ounces, you run it out. And then we just calculate it. So we want greater than 1,100. We don't know the probability, so leave it blank. And we calculate. And that's about 11% chance. Okay, rounded to the nearest 2 decimals, 0.11. Just note on the assignments, um, it's a good idea to put in a whole bunch of decimals. If it tells you to put, 2, make sure you round to the nearest 2. If it tells you to put 4, round to the nearest 4. If it doesn't say, just put a whole bunch in. Okay, now part C. You want to be 99% certain that you'll not run out of ice cream. How much do you need to have in stock at the beginning of the day? Okay. So if you want to be 99% certain you're not going to run out of ice cream, that means there's a 99% chance that probability that X is it going to be greater than a certain number or less than a certain number is 99% for what you want to stock. It's not greater because, see, if it's greater, then you run out. If it's less than, you don't run out. Does that make sense? So X is less than some number. I'll put question marks. Is equal to 0.99. Any questions on that? Because not running out means you didn't sell much. Running out means you sold a lot. So the probability of not running out means didn't sell much, which means less than a number. Now we can go to the calculator, click less than, and that's the number we don't know. We leave that blank. The probability is 0.99. And then you hit calculate, and you get about 1,229.16 ounces. So that means you need to make sure that you need to have 1,229.16 ounces of ice cream. Okay. It's very important, by the way, in business to get these things right because if you get it wrong and you run out of ice cream, actually, that's really bad for your business. Because then all of a sudden everyone hates you because they walked in your store, in your ice cream shop, and you say, "Oh, I'm sorry, we don't have any ice cream left." They're never going to come back. So that's why you got to be very certain. 99%, it might be enough. Certain enough. Any questions on these ideas? Hopefully you understand kind of the normal distribution and how to use this calculator. The interesting thing is I actually redesigned this calculator last month because someone gave me a suggestion. And I thought it was going to take days to code in this part. And actually, I asked Google for one little hint on something that I needed some help, but I gave the whole description of what I want to do. And actually, Google wrote all the code with AI. It's a new world. So turned out I didn't code much of this. Artificial intelligence coded most of this. And I didn't even ask it to. I just asked Google. I didn't realize I was asking artificial intelligence, but I was. So that's the new world we're in. It means I had a lot more free time than I thought over winter break. But this calculator, like I said, someone suggested I change it to make it easier, and now it's easier than it was last quarter. So that's my newest piece of this calculator. Actually, there's one that's a little newer, but that's a really small thing. You may not never even notice. Okay, so the last thing to do is the secret word. Again, this is one of the easier of the class in terms of the week. So it's kind of a shorter webinar, but you have your project to do and an exam. And the secret word is symmetric because the normal distribution is symmetric about its mean. Left and right are the same. So that's why I figured that'd be a good word. It's not one you just guess randomly, but it's one you'll understand and maybe remember, but write it down and then make sure you put it in the secret word place. So that is the secret word is symmetric. And then again, big reminder, week 4 exam has to be done by Sunday. I recommend a little earlier because that way if something happens, you're in better shape. Especially if you live in Tahoe, we might have some weather. Not a big storm, but you never know. We could lose our internet. So hopefully we don't. So if I don't get back to you on a question for a while, that means I have no internet because we had a windy, stormy day. And hopefully you'll understand I can't do anything about it. So anyhow, the other biggie is make sure you get your project idea posted very soon so you can start working on your project. It's not the kind of thing you're going to do in a day. So make sure you get that down. Work with your partners and come up with a good idea. Post it on the Project One discussion board, and then I'll let you know if it'll work, and then you can go collect your data. And that should be done this week. Make sure you have all your data collected. I would say probably the next like 2 or 3 days, maybe 4 days is what I recommend. I'll give you time to write. Okay, and get help and stuff like that. And for example, Hector can help you in those kind of things. I can help you, and so can the other tutors. So that's about all I have to say for today. It's a bit shorter because there's a little less to talk about. Okay, next week is actually a lot harder than this week, and that's how it goes sometimes. Don't blame me on this one. It's just some topics are harder than others. This is one of the easier ones. So I am going to stop the recording.